Leo, it should be live now, is it not? Leo? Yep.
Can you send me the screen slot? Or we just
Okay, welcome everyone. Oh, the lighting's dark, man. I'll just see if I can fix that. 1 second. Okay, welcome everyone. Welcome back to COMP1110. Sorry for that slow start. There's a few technical issues we ran into, and also our mathematical friend has run over time again. So anyway, let's get on with it. First of all, I've got a bunch of admin. The assignment was supposed to be out right before the lecture, and it was all good to go, and we hit a technical hurdle, or at least the tech people hit a hurdle right before I pressed the go button. And they're going to get back to me maybe during this lecture, and if it's all good, I'll release it during the lecture. There was just some small technical problem with the assignment. Anyway, so the assignment 1 will be available very, very soon. Now the next thing, oh, hang on, have I got, oh, man, sorry, just let me make sure this is recording. Okay, we're good, we're recording. So the assignment will come out very soon. Welcome back to COMP1110, everyone. First of all, last week we had people from the marketing thing who are very interested in what we're doing for some reason, because we're, by the way, this hybrid thing where we've got in class and on the live stream is a whole new thing for ANU, so that's why they were here. Anyway, they filmed. If you were sitting right around there on Friday and you don't want to be in their little how to give a lecture video, then go to Piazza and there's an email address there, and you can yell at that person and say, hey, please blow my face out, or please, delete me or something. But it's just a little snippet of us having a dialogue that's apparently going to appear in that little teaching video. It's only for people who are learning how to teach. All right. Now, is this my mic at the back there? Can you hear me nice and good? Yep, great. All right, next on my admin list here, let's go to admin slide. Next on my admin list, you should have all enrolled in your labs now. The labs are going to be finalized tonight, so set in stone. There's quite a lot of spare spaces in quite a few of the labs. Some are full, but there's spare slots in any of them. So please pin that down probably before the end of the lecture, probably in the next hour or so. Pin that down, because after that it will be very difficult for you to move, okay? So if you've had difficulty moving, there are 1 or 2 people who've already talked to me one-to-one about their situation waiting for enrollment codes and stuff. That's all taken care of, don't stress about that. But for everyone else, make sure you're in the lab you really want to be in, because that'll get kind of set in stone very soon. Something I didn't emphasize before, which is important, we have a lab exam in this class. We have a lab exam. The lab exam is in week 4. okay? And what's in the lab exam? Well, normally we don't tell you what's in an exam, right? Except at the most abstract level. Not true. Not true. In this class, for the lab exam, we tell you exactly what's in the exam, okay? What's going to be in the exam is a random selection of the homework questions from the first couple of weeks, okay? So if you do all the homework questions, and you're allowed to get help from anyone with that, including the one-to-one consultations, your tutor on Piazza, go through those homework questions, and some random selection of those will pop up in the exam, okay? So you get to sit there in that exam and solve the questions. Every question there is one that you will have already seen, at least had the opportunity to see, okay? This is not supposed to test memory or anything like that, obviously, because you've already seen the things. It's more just trying to test whether you've got basic competency and you can know how to drive IntelliJ, know how to make sure your program works and so forth. Yeah, question from the front. The lab exam, yeah, traditionally the lab exam was in a lockdown lab, and you'd use the lab computers and it'd be invigilated. Not so this time around. So be using your own computer unless you're in a physical lab, in which case you can use the lab computer, but it'll be the same. There's no real difference there. Yep. So for the people who are doing this virtually, you'll just be doing it from home. Your tutor will be there and your tutor will be asking you questions. Your tutor may ask you to explain stuff that you've written. So just do the right thing. And like I say, if you have prepared for this, this should be a fairly easy thing to get through. Yeah, question at the back there. You have to speak real nice and loud. Honesty, I guess. Integrity would stop you from behaving badly. That's about it, okay? So we expect you to behave with integrity. That's an underlying premise in this class, okay? We have more rigorous, we go to greater length in the actual exam. The lab exam is something where we've already shown you the question, so there's not a whole lot at stake here. We just really want to make sure you know what you're doing at this point. It's week 4, we want to make sure you know what you're doing. And the tutor may ask you to explain stuff you've written, so if you can't explain it, then there's going to be a problem, okay? By the way, that's true at ANU for nearly any assessment. Any assessment like an exam, an assignment or so forth, you can be given an oral for it, okay? So if someone says, hey, how did you do this part of the assignment? You could have an oral exam on that, and the oral exam could override the other, okay? So you always have to be able to explain what you've done, which is not very surprising. But there are ANU rules about that, and so that applies to all of our assessments, of course. Course website, make sure you're familiar with the course website. I can't stress this enough. Some people don't realize the lectures are actually here. The lecture recordings are actually on the course website. So if you go here, go to lectures, and you go here, you go to Java, and these are the units that we've already gone through. It's a bit slow to load. Why is it slow to load? I've got this massively fast connection here. Anyway, you can see all of our lectures. They're all neatly organized, or you can see complete lectures if you want over here, if you prefer to watch them as monoliths. Okay, and today's lecture will appear there in a few hours. So please use that. They are also available on Echo, but they're not neatly organized. They're just slapped down. So I'd encourage you to use the course website because they're all structured and organized in terms of the different learning units. The other thing I want to very quickly show you is that the Waterloo visualizer things are here. I have tried to show you this before, but also the in-class lecture code is here as well. So if you click on that little picture of someone with a laptop, hopefully our live stream is going okay because I'm a little bit afraid of how slow this connection is. All right, is the live stream going okay, Leo? He's in a virtual world instead of the physical world. Thumbs up. All right, good. So this logo here means lecture code. All right, I just want to emphasize that because I notice a lot of people aren't on top of what's on the website. You really should become familiar with that by now. And then what else did I want to go through? Yeah, these homework exercises. If you go here, where is it? Homework exercises. This is the homework exercise thing. You go there, and you'll see it says homework for J02, and it'll have exercises there that you can do. It asks you to do an exercise, and there's tests there and everything. So that's what you'll be examined on in the not mid-semester exam, in the lab exam. All right, and I think that's it. Oh, when the assignment comes out, which hopefully will be in a matter of minutes or hours, when that comes out, one thing I want to emphasize is that the assignment is supposed to be completely doable by every student in this room, okay? But there are questions there which I'm only expecting HD and D students to get, okay? So the assignment is staged. There are parts there which I expect everyone to get. Then there are advanced bits that you should not attempt unless you're really gunning for a HD in this course, okay? Please don't attempt it. It is deliberately difficult. It's discriminating, okay? So there's parts that are actually really quite hard, and there's a whole bunch of stuff which you should find quite doable in the time available. You've got 2 weeks to do it in. It should not be a stress, okay? If you're trying to do the HD stuff and you've never done Java before, you've never done programming before, and this all seems very foreign, that's probably not a good strategy, okay? Don't forget, the assignment is redeemable, okay? The assignment's redeemable. Okay, so things are staged. So the early parts and all the tests have listed next to them the grade level. So it's got pass test, credit test, distinction test, and HD tests. Okay, it's all very clearly laid out for you. Now what else was there? Okay, I think with that we can move on back to the class. Any questions? Does anyone have any questions about anything administrative relating to this class? Nope. All right, terrific. Let's keep moving on. J5, this unit is about control flow, the first unit of control flow. Now you remember I said there were 3 components to execution. What were they? They were sequence, selection, and iteration. Do you remember that? Sequence. This is imperative programming. There are 3 elements to imperative programming. You guys should know this. I've repeated this a few times now, so it should become familiar with you. There are 3 elements to imperative programming. If you're using an imperative programming language, you'll find sequence, which means unless anything else happens, we'll do the next instruction after the one before. Okay? Sequence. And then we've got selection, which says that we have special ways of choosing to go left or right, this way or that way. And different programming languages do it differently. But a common way we do that in many programming languages is an if-then-else phrase. Okay, that's got something like an if-then-else. And the other one we're going to do today is a thing which is called a switch statement, which is like an if-then-else, but is a little bit more general. All right? So, and the last thing, which is what we're going to do later in the next module, J6, which we'll come up to in a short while, that deals with iteration. Iteration is when you loop, which is a really key concept, okay? So let's just repeat that again. Sequence means we do one thing after another. Selection means we can choose between this way and that way. And iteration means we can repeat. And with those constructs, you can do a lot. One of the second from last things we're going to do in today's lecture is when you can wrap something up, you can encapsulate it as an idea, and we call that a method, okay? And you can go and do this method. All right, let's keep moving through here. Does anyone know what's going on in that picture? Yep. Yeah, well, it's actually what they call computers, okay? Those people back in the day, that photograph, I can't remember when it was taken, perhaps in the 1930s. In the 1930s, those people there are what they used to call computers, meaning it's a person who computes numbers, okay? This is before and then later on when we invented what you all think of as computers, they called them mechanical computers or electrical computers. And in fact, our top peak body for computing amongst researchers in the world, I'm a member, is the ACM. Does anyone ever heard of the ACM before? The ACM is where our great awards come, like the Turing Award and so forth. It's a very, very important organization. It's where our major conferences and publications come from. Do you know what ACM stands for? Association for Computing Machinery. Okay? It's a very old organization, and they call it computing machinery. That's because that was to differentiate it from organic, human computers. Okay? And that's exactly what's in this picture. Anyone have a clue what they might be doing there? They could be doing something for the tax department or something like that. There were lots of places that used lots of computation to do their work in those days, and they have rooms full of people doing it. But what happened later on, they were called computers, and they called this a tabulation or calculation factory, okay? So in the 1930s. Later on, this happened. Can anyone see what's going on there? That there is the world's first fully programmable computer. There was the ENIAC. There are other computers before it and around it which had different properties. This is the world's first fully programmable electronic computer, because there was a mechanical computer before this. Okay, world's first fully programmable electronic computer. And anyone have any idea what all that squiggly stuff that looks like spaghetti is on the wall? Anyone guess what that is? Yep. It's wires, yes, very good. Can anyone lift the level of abstraction slightly? That's the program, okay? That's how you program. You program by moving the wires around, and that's how you wrote your program, okay? You wrote a program by literally moving a bunch of wires around. So you set up the wires, and then you pull the big lever, and out came your number, okay? So that's how you wrote a program, is with a whole bunch of wires, okay? And what did they use it for? Well, it was developed during World War II, and one of the motivations for that, sadly, was to develop artillery trajectory tables. They needed these tables in the army because they needed to know what range they were going to get out of a shell at a particular angle with a particular elevation and particular winds and all the rest of it. And so gunners had these tables that you can see there on the right. These tables every gunner had one of these things, but they were hand calculated, and there's a lot of data points on there. They were hand calculated, and there was a lot of demand for these things because they were inventing new cannons or whatever it was, new artillery. And so there was a lot of pressure on the ability to produce these tables, and so that was one of the motivations to produce an electronic computer to replace the human computer. Okay, so this is the beginnings of computing, and then what we see here, I already showed you a picture of this device before. Can anyone remember what this is? This is a loom, right? This is a jacket loom, and it's used for weaving fabrics or carpets and things like that. And it's very ancient. And what can you see what it does in terms of imperative programming? What is it able to do? Can anyone remember? It can do sequence. Each one of these things is like a set of instructions to do at one shot. So it sets up all the threads in the loom in a certain way, then something happens, and then it changes to another way, then it changes to another way, then it changes to another way, and so forth. And then you get this beautiful pattern on the cloth or the carpet, right? So that does sequence. Each one of those is a step in the sequence. It also often does iteration because you can keep going and repeating the same pattern again and again. But it doesn't do selection. It doesn't have two different branches. As you can see, there's a single track here. Today we're going to do selection. So you can do A or you can do B. All right? And there's your beautiful jacket loom. So control flow statements allow the execution of the program to deviate from a strictly sequential sequence. Okay? Hopefully you're getting this. There's a sequence by default, but you can deviate from that with a control flow statement. And the way we do it in Java is we have if-then and if-then-else statements. Now, if you notice, I've been fussy with the typesetting of this. Notice how the then statement, the word then is not in that typewriter face. That's because in Java we don't actually type out then. In some languages you do. You say if something, then the other thing. In Java that's silent. It's a silent then. Okay? But you can when you see the statement in your head, you might want to read out the then. We don't actually write it though. Okay? There's no then in there. It's just an if statement. Okay? And I've done that consistently up there. And an else statement says do A under certain conditions, or do B if that's not the case. Okay? So you can do A or B. If you don't have the else clause, then it will just do A if the condition holds. Otherwise, it'll do nothing if the condition doesn't hold. It will just do whatever comes next. Okay? So there's a condition, like, what could be anything. The person is over 18. That's a condition. If a person's over 18, then you can do this thing. Otherwise, you just continue. Okay? If there's an else clause, then you can say, if they're over 18, do this. If they're under 18, do that. Okay? A and B. Remember, folks, the way I lecture, I'm going to go through this hopefully fairly quickly. Then we're going to jump into code, and you get to ask me more questions, and we'll see how it really works when we write code that does this stuff. Okay? The switch statement is a more general form. What the switch statement allows us to do is allow us to choose one path among a series of different options. So the if statement says this or that, depending on a Boolean. Remember, Booleans can only have two values, right? True or false. So an if statement uses a Boolean. A switch statement can take some other value and say, depending on what that value is, do this, or that. Okay? So we've got switch statements and we've got if statements. Now, what's important for you to know, which is handy, because some of you think, oh my God, this Java is such a pain. This construct that I'm talking about, some of you probably already realize this, is actually common to many languages. In fact, most imperative languages have this. So if you learn this stuff, you'll be able to carry it across to other languages as well. All right? The details of exactly how they format the keywords and stuff will change, but the key concepts remain the same. The switch expression will select one value among many, and execution jumps to the first matching case. Okay, so I've got a whole lot of things that it could match to. So at the start of the switch, it will see what your argument is, and then it will jump to the first one that matches. then it will just continue doing sequence. Remember, sequence goes like this, unless there's a special word which we call break. If the special word break is there, then it jumps to the very end. If the word break isn't there, it'll just keep going and doing all the instructions that follow. Okay? The value of the expression is given by the yield operator for a matching case. In a matching case. All right, so now we're going to do a mini quiz. Hopefully this will work a little better than last week. Let's just see. I don't trust Piazza, but who knows, it might work. There you go. That should have released J5. If it didn't, I'm sorry. And with that, we're going to go and jump into some code. And I will change the view here. We're going to jump into code and write down some control flow for if then else. So the first thing we're going to do is create ourselves a new class in here. New Java class. And the class will be called COMP1110 lectures. Well, actually, if I do it, yeah, COMP1110 lectures. All right, it's a very long name for a class, but there we go. All right, so I often get burned by this. So depending on where you put your mouse, it's actually created a package inside of a package, so it's got a very long and silly package name. That's my mistake, folks. So let me try and fix that. So what I'm going to do is rename this. If my keyboard would work, there we go. And I'll do a refactor rename. All right. And that's not the way to do it. Refactor, and then we're going to move it. Okay, refactor, move class. Okay, we're going to move it into a different package. The package is going to get rid of all that silly stuff which I accidentally duplicated. All right, refactor, and does not exist. Do you want to create it? Yes, I do. All right, there it is. Let's move it down there, and we've got the silly dead one here, which we're going to delete. Press the delete key. Yes, we do want to delete that empty package, and we're back where we should have been. Sorry for that delay. All right, here we are. Now, if I want to write a piece of code and I want to make it executable so I can run it, what do I need to do? What's the pattern, folks? You should have been remembering this now. I need in Java to put that boilerplate. What's that boilerplate that I need? Yeah, public static void main, and with the shortcut is PSVM. That's right, like that. All right, great. And then what we're going to do is we're going to declare two booleans, because remember, if statements take a Boolean argument, true or false, one or the other. It's got to be true or false, okay? So if statements can take a Boolean argument, true or false. So I need to declare a Boolean if I want to write some sample code here. So the way I do that is I say Boolean A equals true, maybe? I'm making this up. True, I'm also mistyping. Boolean B equals false. There it is. And then what I'm going to do is I'm going to say if A is equal to true, and B is equal to true, then what's the case here? What must be happening if that's true? If I write it in English, if I want to write something out here, what would I say here? They're both true, right? They're both true, right? Now, what do you expect to happen here? What's that? Yeah, nothing's going to print out, right? Why will nothing print out? Okay, because what's going to happen is the program will go here, it'll make A true, B false, then it will come here and say, are both A and B true? No, they're not. So it won't do this, and then it will jump to the next line of code, which is the end of the program. Okay, so you're absolutely right. The answer is right. Otherwise, what's going on here? What's an English way of describing, what's the best, most general way? I've forgotten my shortcut there. I didn't type it right. What can I write here in English to describe the situation we're in now? What's the most precise English description of our situation? Yep. A or B is false, right? Can we say it slightly more succinctly? Another way to say it is at least one is false, right? We can just say that. At least, oops, caps lock. At least one is false. Okay? At least one is false. All right, so now let's try and run our program. And remember, the quick way to do that is to go here, press the right shift or your control click or whatever you're doing in your computer, and you see down there at the bottom of the screen, it's building. There it is, it's building there. And at least one is false. Correct. Correct answer. And if I go like this, like that, we should see that both are true, because both are true. So A equals true, B equals true, both are true. All right, we're running it, we're building it down here, and then look over here and it says both are true. Yep. Question.
Question for an online student. Why don't you need the braces up if
Great question. Why don't I need braces? Does anyone know the answer to that question? It's a very good question, but it's also got an answer I gave last week. Why didn't I use the curly braces? Yep. I didn't hear you. I still can't hear you. Anyone else got an answer? Yep. It's a single line. That's right. It's a single line. And the purpose of the curly braces is to group multiple lines to make them look like a single line. Okay? So if you use the curly braces, it allows you to group a series of statements to make them behave like a single statement. Because I've got a single statement already, there's no need for the curly brace. We can put them in there. It won't hurt us to put them in. Let's just do that. So no one's got any anxiety here. No, true story. A lot of people think it's very important to put these braces in. It's like the people who go and turn the little red thing on the power outlets off so the electrons don't drip onto the floor. Same deal. All right. I joke. There's actually good reasons for putting the curly braces there. Some people think that if you do that, you're less likely to make a mistake about what's going to get executed and what's not, which is probably true. So sometimes it's good practice to put them in. You don't need them. That's my point. You don't need them here because it's a single statement, right? Curly braces allow you to combine a bunch of statements, and I wanted to demonstrate that to you. All right. Now, let's do something more. Let's go and, okay, that was only two situations. How many situations can I get if I've got two Booleans, folks? If I've got two Booleans, each one can be true or false. It's like if I've got two coins and I toss them, how many different possibilities can I get there? Yeah, great. I can see 4 fingers there, 4. The answer's 4. Okay, so let's write all 4 cases out now, long-handed, which sounds a little bit boring, but just to be really, really explicit and clear about what's going on here, okay? So let's go and do that, and I'll just do something like this. Oh, one more thing. Can anyone else see something that I did that was unnecessarily verbose? I did something else deliberately in a verbose way. There's a shorthand way to do it. Yeah, at the back there. Yeah, I didn't actually need to say that, because what's going on here? We're taking a Boolean, A, which is either true or false, and then I'm comparing it against true. But it was already a Boolean, so I'm making a Boolean from a Boolean, and it's going to have the same value as the Boolean I started with, which is kind of silly, right? I could have just written this. Because remember, A and B are both Booleans. So I can just do that, all right? It's exactly the same. I deliberately wrote it longhand so it was completely clear to you what was going on, but we can see that that's got exactly the same meaning. Is A true or is A false? And is A true and B true? That's what that means if we spell it out long-handedly. All right, so now let's go here and say if A, now what's going to sit in here? I do need the braces now because I'm going to have more than one statement in this piece here. And then I'm going to have an else statement. Else, what can I write here by way of a comment to describe everything that goes in this part? What's going on here? A is false, right? Sometimes it's useful to do that. It's not very helpful here because the code's so small, but sometimes when you have a lot of code, it's good to remind you why you're in that situation. You're in that situation because A is false, right? So if A is true, then I can now test for B. I can say if B, then what should I write here? What can I say in English here? Yeah, both are true. Okay? And then what can I say here? Else, what? Yep. Correct. A is true and B is false. And then down here, I can say if A, then what can I write here? A is false. Sorry, did I do something wrong? Oh, sorry, if B, yep. Very good. So those of you on the live stream, I was just corrected there. I made a mistake. I want to make lots of mistakes. And what can I write here in English? They're both false. Yeah, right. They're both false. Both are false. Okay, let's run this. And we should get, in this case, what? We should get both are true, right? Because A is true and B is true. So it should go here, A and B, so it'll do that. Then it'll come down here and say, oh, A is true, oh, B is true, and it'll print that. So we've got both are true printed out twice. Once up here and once down here. Okay? If I change it to this, like this, let's just see if it did the right thing. Now, folks, if we go to the Waterloo Visualizer, I think what I've just done here is in the Waterloo Visualizer. I think I put it up before the class. A is true, B is false. That's exactly right. A is true and B is false. Okay? You can mess around with this and satisfy yourself how it's working. But you can see it's switching and doing different things according to what we what A and B are. Now what we're going to do is we're going to create another class here called new Java class, and it's going to be called control flow switch. Control, like that. And we're going to put in here, add it to Git. Yep. I'm going to put in here, I'm going to create myself a main method again, PSVM, like that. And then we're going to have a variable here called C, an integer C, and we'll give it some literal value. A literal value is when I just type in, I'll just type in the value 2, just for no particularly good reason. And then we're going to do a switch statement, which is going to choose which one to do depending on the value of C. Okay? And we can say switch, whoops, switch, and then I just put the argument in there, like that, and I wrote my switch statement down here. Now, I can differentiate the different cases by using the keyword case. So I can say case 1, and then S out, I can say C, whoops, I can say C is 1. Okay? And then I can write a case statement for B, for 2. Case 2. All right, if I run this, what should get printed out if I run it right now? Anyone know? What's going to get printed out if I run this right now? Let's run it. Quick, any guesses? Quick guesses from people in the class or online. What will get printed out? C is 2. Any other guesses? All right, put your hands up if you think it's going to print out C is 2. Okay, and if you're not sure, put your hand up now. That's fine. Okay, you're allowed to be not sure in week 2 of semester. That's perfectly acceptable answer. Not putting your hand up is the bad answer. Not putting your hand up at all is the bad answer. All right, let's run this. And, whoa, I ran the wrong program. See, it's the people who didn't put their hand up were right because I was going to run the wrong thing. All right, let's run the correct program. There it is. And we should say C is 2. Why? Because C is 2 up here. Then it says switch on C. It'll go here and it'll say, is C 1? No, it's not. Okay? So it won't do that. It'll come down here and say, is C 2? Well, it turns out it is. Okay? Now, if I do this, what's going to get printed out? Anyone? C is 1. Great. Any other suggestions? Okay. Whoa, you guys. So we've got some people saying C is 1. Some people saying C is 1, C is 2. And now I need hands up. I really need a vote here. The third vote will be you're not sure, which is also acceptable in week 2. So C is 1. That's one option. Hands up for that. Okay. C is 1, C is 2. Hands up for that. And not sure. That's okay as well. All right. Great. Let's find out, right? The best way to do it is to find out. And what's interesting is not which way you voted, but why that answer is true, okay? And look what happened. The person over there was correct. It is printing out both. C is 1 and C is 2. Why? Why is it doing that? Okay, so let's run through it. C is equal to 1, right? Okay, good. Then case 1, okay? Is C equal to 1? It is. Great. So we print this out. That's what everyone thought. Everyone agreed. I think, except those who were not sure, everyone agreed that was going to get printed out. But then what happens next? Well, there's no control flow statement here. We need a break statement if we want to change the control flow. And there is no break statement here. Okay? So without the break statement, it will just do, what's the word we use for iterative programming, for imperative programming? Sequence. It'll just do the next thing in sequence, which is down here. It'll skip over that thing and come here. Okay? So it's going to do both. All right? So how do we fix this? We put a break in here. And this is how we normally write switch statements. We normally write them with breaks in there. Okay? like that. Okay, and then we run it now, and we should see what many of you thought we're going to see in the first instance. We should just print C equals 1, and then it will break and go to the end of the program. Any questions about that? All right, C is 1. And then the last thing is, what happens if we do this? Anyone know? Yep, what do you reckon it's going to do? You have to speak real loud. It won't print anything. Any other suggestions? Okay, put your hands up if you agree. It won't print anything. Yep, that's right. And the majority of people in the room put their hands up for that. Okay, so the answer is, by the way, you all can vote online by just saying what you think is going to happen. So C equals 7, it'll come here, it'll say switch on C. Is it 1? No, it isn't. And then it'll come down here and say, is it 2? No, it isn't. And then it'll come down here, end of program. Okay, so nothing gets printed out. Let's just run it so everyone's confident that's actually correct. Now, can anyone remember, there's something I haven't covered, I haven't put in this code that I did explain on the slide that would help us here. Yep. Beg your pardon? Yield. That, I'm not sure, I've forgotten why that's even there. That is actually not a keyword we normally use, but what we can use here is, there's something more significant. What is it? Anyone know? There's a special kind of case we can put in here. A catch-all. Does anyone know what the catch-all is? Yeah, default, right? We can use default, which means everything else, okay? So let's try that, and as you saw there, it printed out nothing. Let's try that now. We'll say default, and we'll say yep, and let's run this. And I've got a question down the front here. Yep.
Can you have cases being like case every even number?
Can you write a function here? No.
Like case.
No. It's just a literal here. Or it could be a variable, but it's a single value.
You can only do everything else, or
Yeah, it's a single value here. Yeah, so you can't have some fancy thing that says just prime numbers, please, or something like that. You've got to actually literally say what you want.
Can you say case 1 to 3?
You can do that. Yeah, you can do this. You could say case, what is it? I think you do it like this. Case, you can collapse them. If we do that, oops, I've written it the wrong way around. If I do that, then yeah. Okay, so I can do that by combining a bunch of cases into one. If we change this back to 9, it'll say it's something else. Okay? All right, let's keep moving.
Hi, Steve.
Yep.
Question from online student. Is switch statement faster than if else?
Is a switch statement faster than an if else? Anyone got any guesses? Okay. Hands up for true. Hands up for false. Hands up for it really doesn't matter. And hands up for not really sure. All right. And the answer is, it really doesn't matter, interestingly enough. Because, and this is an interesting thing, many of us when we come at this, we want to try and work out what the fastest thing is. And the real answer is, just so you all know, my research agenda and what our lab is famous for is performance analysis. And this is like our bread and butter. Okay? Compilers do surprising things. This gets eaten up by a compiler and then spat out as machine code. Okay? Ultimately. And the machine code gets executed by your computer. And trying to predict what a compiler is going to do with a piece of code like that is actually really hard unless you're an absolute expert. And even if you are, it can surprise you, and often does. Okay? So trying to predict which is going to be faster is not going to get you very far. Not only that, but it's actually a bad idea. Can anyone guess why it's a bad idea? Why is it a bad idea to think about that? Well, the answer is if you really are not going to make a very good guess because it's so hard to see through, because the compiler is so smart, it's going to do things that you can't predict, guessing will actually lead you the wrong way, because what you should be doing always is writing for clarity, right? Write so things are clear, not so it's faster, okay? You may get to a point in some of your assignments when you're trying to make things as fast as you can. Be very, very careful when you get to that point, because mostly the issues with fastness live at the level of algorithms, not at the level of if statements. okay? Have you got the right algorithm at all? Rather than, is that if statement going to be faster than a switch statement? It was a really good question from the person online, but hopefully that answer helps you figure this out. All right, let's keep moving. I'm running behind. Right, terrific. Now, next we get to go to, where are we? Alt tab. We get to go to the next part of control flow. So control flow 2 is, now, what did I call this in terms of imperative programming? What's this part? Iteration. This is all about iteration, okay? We're going to do while and do while, for, break, continue, and return. These are mostly, not all, but mostly related to iteration. So, while and do while statements. The while statement continuously executes some block of code, right? You can put curly braces there if you want. You don't have to have curly braces if it's a single statement. You execute that statement or that block until the Boolean condition is false, okay? Now, if your Boolean condition never changes, then it's either going to execute it once or forever, right? If you had some Boolean just typed in true, while true something, it's just going to keep going, right? If you said while false something, it'll never happen. If you said while x is something and x changes somewhere, then when that condition changes and evaluates to false instead of true, then it will stop, okay? But that's how a while loop works. It won't execute the block of code unless the statement in front of it is true, okay? A do while loop is very, very similar, but the condition's at the end. So it does the following as long as the condition is true. Very similar, very subtle difference. It's useful sometimes to do it the other way around. We usually write while loops. Sometimes it's useful to do the thing first and then test the condition. Usually we test the condition and then do the thing. Both are fine. And the first is done with a while loop. The second one is with a do while. We're going to work through some code shortly. Okay. The for statement is just a convenient way of doing iteration in the case where you have an index that's going up. You say for I equals 0 to 10, and it'll go through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then stop, okay? And so it's a stylized form of while loop, if you like. So whenever you've got a for statement, you could have rewritten that as a while statement. That's very important to understand. So if you have a for statement, you could have written that as a while statement. But for statements are often a nice way to write it. So it's convenient for certain styles of things. So we use for statements a lot when we write programs in many languages, including C and Java, Python, and so forth. We use that style, okay? Just because it's a specialized form of while statement that's often handy. There are three parts to the for statement in the parentheses. One is the initialization. Normally that sets up a variable, say int I equals 0. So you're setting up I to be equal to 0 at the start. Then you'll have a termination condition which says I is less than 5. It means keep doing this until I is less than 5. Notice it's a termination condition, not a continuation condition. With the while loop, the condition is saying, please do this until this is not true. So it's like a continuation condition if you want to think of it that way. Whereas in the for loop, it's the other way around. It's saying, do it until this is true. Okay, so they're kind of inverted. And then finally, we'll normally have an increment statement. So it says increment I by 1 or increment by 2 or whatever you want it to do. All right, that's a construct. And we also in Java have what's called an enhanced for statement where we can infer the initialization, termination, increment statements if we've got a collection. So if you've got the simple example of going through a collection, you can just sort of say, go through all the things in this collection and it will take care of the details for you. It's just a nice stylized way of doing that. We'll go through a worked example. And you'll see there's a lot later. Branching statements, a break statement, it terminates a loop construct. An unlabeled terminates the loop in which it's called. A labeled one terminates the loop named by the label. I'm not going to go into that in detail, but the basic thing is you can stop a while loop if a certain condition happens right in the middle of the loop. Normally you stop a while loop when the condition at the top fails, but something may happen partway through the loop and you're like, I want to get out of here. You can use a break statement for that, okay? A continue statement skips and goes on to the next iteration. So you're partway through the code in the middle of a while loop, and something happens like, oh, I'm done for now. Let's go on to the next item. So a continue says, let's continue. Okay, so you skip over the rest of the loop and jump back to the start. And a return statement just exits the current method. Okay, this is another form of control flow. We haven't introduced methods yet. We're going to do that in just a few minutes. But a return statement says, okay, I'm done with this method. Okay, there's one example in Java where we've got an implied return statement. Can anyone guess what an implied return statement is? In the main method, we don't say return at the end of a main method. In fact, any method that returns nothing, in Java the word void is used to describe that situation. If it returns nothing, then we can just don't need to put a return statement in there. If it returns something, we have to give that thing that it returns. We're going to come to this soon. Okay, don't worry about that. We'll come to that in just a few minutes. Mini quiz. Hopefully the last one worked. And here is the next one. Okay, and we'll now move on back to code, back to IntelliJ. And we're going to write some code with loops, iteration. Yeah, control flow while is what we're going to do now. So we're going to create a new thing here. So it's going to be a new Java class, j06 dot control flow while. There it is. And we will again give ourselves a main method so we can run this thing. Boilerplate there. And we're going to start off with declaring a little variable. We're going to call it I. And we'll set I is equal to 1 for no particularly good reason. And then we'll write a while loop like this. I'll say while I is less than something. So that's condition. And then we'll do something like we'll say okay? So what we've got there is we've declared a variable I. We've wrote ourselves a while statement with a conditional in there. The conditional is checking whether I is less than 3 or not. And then inside the while loop, we've got a statement we're going to print out to the terminal. All right, so now I want suggestions as to what is going to get printed out here. Yep. Yep, I couldn't hear so well, but I think what I heard was it's going to continuously loop printing out that line in the middle. Yep. Anyone got any other suggestions as to what might happen here? Yep. What's that? Yeah, it will never terminate, which I think was what was said over here. So it's not going to stop. Why will it never terminate? Why do you think that? Yep.
I is never less than 3.
Right. Why is I never less than 3? It says I is less than 3, which it is at the start, right? Then it comes back up here, and nothing's happened to I, so it's just going to stay there. So it's just going to go round and round and round. Let's just check if she's right. Let's have a look here. Now it's building it over here. Oh my goodness, see, it's running and running and running. You can't even see, but it's making, this buffer is getting bigger and bigger and bigger over in the corner here. Okay, so now I need to stop that little red square, and that stopped our program, because our program was continuously printing out this line. And it said that it stopped with an interrupt signal. Interrupt signal was generated by me pressing that red square up there in case it ever happens to you. Don't panic, your laptop's not going to catch on fire, it's just going to keep doing this until you stop it, right? The way you stop it is with that red button there. Okay, so what would you suggest we do here? What might be something else we could do? Yep?
We could either change I each time.
Yep. Yeah, let's try doing that. So let's change I, and we can just print I out. Why don't we just print I out here, like that, and we'll change it. I equals I plus 1, like that. All right, so now I is getting bigger each time we go through the loop. Now what do you think is going to happen? Anyone else want to take a guess at what's going to happen now? Yep. No, sorry. Yep. It's going to print I as 1 and I as 2. And anything else? He says it's going to print I as 1 and I as 2. Has anyone else got any other ideas about what it's going to print out? Should we see if he's right? Let's have a go. By the way, folks, online, I know you've got a tiny bit of lag there, but if you have any suggestions, please just jump in. Okay, let's run it. And we saw it. I is 1 and I is 2. He's exactly right. Okay? So it printed out I is 1, printed out I is 2, then it added 1 to I, so now I is 3, goes back to the top of the loop, and it says, is I less than 3? No, it's not, so it stops. Okay, so we've terminated the loop. Now what we're going to do is we're going to write ourselves a, oh, by the way, does anyone know how we can write that more succinctly? Yep. Did you want to say something? Plus, plus, yeah. That's a shorthand way of doing that. We can use the unary operator. Unary means it operates on one value. We say I plus plus, like that. And just, that's not a big deal, but just so everyone knows, we can do that. It's a more succinct way of saying it. It's a very common thing to do in programming, so we just have a shorthand way of doing it. So it means I, grab the value of I, take whatever was in there, add 1 to it, and put it back in I. Okay? So it has the same effect. All right, now what we're going to do is a do loop, a do while loop. So we say do something while I is less than 5. Okay? And then what I can do is say, I'll say while. There, and I'll cut and paste here. All right, what do you think what's going to happen now? Anyone want to guess what's going to happen now? Anyone else? What's going to happen? Well, it's going to do the same things it did before, plus something else maybe. What's that plus something else? Yep, front. It's going to say do I is 3 over and over and over and over again. Why? Same thing as we saw before. We haven't changed I in that loop. So I is going to be less than 5. It'll do the thing. And then I is still going to be less than 5. It'll do the thing. It'll just keep doing this again and again and again and again. So that's not very sensible. And I gave you a clue by accidentally leaving a blank line there. We want to put something else in there. So, right. So that's not very smart. So we want to stop it again. I'll press that little stop sign there. Okay, so what we probably wanted to do is something like this, I plus plus, like that, and then we can, I should have asked you what it's going to do, but I think you can guess what it's going to do. Actually, I actually wanted to ask you what it's going to do because it's kind of interesting. Because the whole point of this exercise was to show you that it will always, let's just do this. Let me change the script here. What's going to happen now? Anyone know what's going to happen now? Right? I is already 3, so nothing should happen, right? Yep. Yep, I couldn't hear everything, so I'm just going to guess what you said. It's going to do this stuff as usual, but then it gets down to here, it'll do this stuff, and then it will stop. So we'll actually print this line out as well. Okay? That's what he suggested. Yep, question? To print something out afterwards?
Like, for example, in the while one where you have like I is equal to 3.
Yep.
We wanted that second one, so we wanted to print while I is 1, 2 I is 1, while I is 2, 2 I.
Oh, I see. Have them interleaved?
Yeah.
You can do that. It's a great question. Okay, I think I'm going to come to that in a second because that's a really good question. It deserves a separate answer. Let's run this and see if it does what he said. And then I'm going to answer this question, which is a more involved one. Okay, and that did do exactly what he said. So print out while I is 1, while I is 2, then it said I is equal to 3. Okay, and if you're confused about that, I strongly recommend you step through things on the Waterloo visualizer. I've got links on the lecture page. Let me just show you again. For those of you who've forgotten, well, where are we? We are down, control flow iteration. You go here, and there you go. If you go here, it's got something very similar to what I just did. Okay, so I strongly recommend you go through that. Now going back to that other great question, unfortunately, the air conditioning is loud here, so I can't, when people are at the back of the room, I can't hear everything you're saying, so I'm kind of guessing half of what you said. But what I did get the gist of was the idea that we want to interleave these things. And can anyone guess how you might interleave things? Well, the answer is you'd have nested loops, which is a really cool idea, but wasn't going to be part of today's lecture, but I can throw it in here just for fun. I can say something like this. Well, this is probably not exactly what you meant, but I'll just do it anyway. Get rid of this, and put a for loop here. Actually, we haven't come to for loops yet. I'm doing that next. All right. I'll do something else. I'll say let's just do something else. Int I equals 1. Just put that back. Then up here, what I'll do, just for the sake of answering this question, int j equals 0. And then I'll say while j is less than, say, 3, do all this stuff. And then down the bottom say j plus plus. Right? Now we've got loops inside of loops. Okay? And what that's going to do, can anyone guess what's going to happen here? Yep. Yeah, it's going to do exactly what we just saw, which is this, and do it 3 times over. Okay, so let's just run that. Now that's probably not directly answering your question because I was guessing at what you're asking me, but this is how you can do interleaving, is by nesting loops. And so what you see here is it did it 3 times over. Okay, it looks like it's only done it twice, but that's because it's scrolled off. It's done it 3 times over. All right. What I'm going to do now is move on to the for loops, which is, and then we're going to take a short break. And I'm only 10 minutes late. All right. Like that. We'll add that. And what we're going to do is start off by doing a for loop, which is like a very special kind of while loop. Now, remember that you can always write a for loop and rewrite it as a slightly more clunky while loop, okay? So for, and then we declare, first of all, we start off by declaring the loop variable. We'll say int I equals, why am I using I? No particular reason, it's just historic. In programming, we very often use I as an index variable because I stands for index. And so we very often write that, and if we want to use another second one, we often just take the next letter in the alphabet and use J, like I just did a few moments ago. Nothing particularly significant about that. You can use whatever letters you like. It's just convention without much history behind it. You could use Z, Y, X. We'd usually choose ones, we usually choose ones that match the circumstance. Like if you're doing Cartesian coordinates, you might use X and Y. If you're using a row and a column, you might use R and C. If you have nothing else, I is a very common default, so just use I. I equals 0. Oops, keyboard issue here. I is 0. Then we'll say while I is less than 4. This is the continuation conditions. Keep going as long as I is less than 4. Then we'll say I plus plus. That's the increment. And then I'll just say S out, and then I'll say for I, and I'm just writing the word for there just so that when you look at the output, you'll remember which part of the code it came from. There's no particular reason for saying that. And then I'll just say what the value of I is, like that. So what you should see now is what? What are we going to get printed out? Can anyone guess? It should say for I equals, and what rows should it print out? Anyone? What it should print out, first of all, is this. It should start off being I being 0. It should say for I is 1. And then it should do what? It's going to increment, which means I will be great, 1 more. So I equals 2, and so forth. And it'll keep going until what? When I gets to 4, it'll stop. It will not do it when I equals 4 because it will have stopped by that point. Okay, so it'll be I equals 3. Go back to the top, increment I, and it's failed that condition, so it won't go. So let's have a look. Oops, I'm running the wrong thing. That's the while loop. Let's just go here, control, run, do the for. Here it is. And there you go, 0, 1, 2, 3. Okay, and it didn't print out the 4 because the loop was terminated. Loop only continued while I is less than 4. Okay, now what I'm going to do is going to use an array. I'm going to create an array just to demonstrate the idea of the other sort of for loops, but let's just start off by declaring an array. Int a, like this. This is a way of statically declaring an array. So 2, comma, I just write some junk in here. It doesn't really matter what these values are. All right, like that. So I've just got a bunch of values in there. So what that's done is it's created an array with those values in it. And then what I'm going to do is say for int I equals 0, I is less than what? How long should I go for it? Anyone know? What is it? Okay, how do we answer my question? What's the high level answer to my question? Yep. Yeah, I want to go until I get the end of the array, which means, as this person just said, we want to know the length of the array. Turns out we can do that. So that's exactly the right answer. So we just say a dot length. Bingo. Okay, so we're going to keep going as long as I is less than the length. Remember, we index at 0, so we start off at 0, and then we stop one short of the length, which means we get all the elements in the array. Good answer. And then we increment I, and then we'll say this, we're going to say S out, something like this, A, and I'll be fancy here and write in the index. So I'm just, remember the plus sign is string concatenation here, and then I'll print out the value of AI, like that, okay? So it should print out A square bracket, then the index I, then a closed square bracket, then an equal sign, and then the actual value. Right, let's run this. And it should print out, as well as the stuff we just did up here, it should print out each of those values in a loop. There you go. Okay? So A0 is 2, A1 is 3, 8, and so forth, and A5 is 17. That's the right way to do it, as the person just here said, because otherwise we'd have to try and count up how many elements are in the array, and if you're like me, you can't reliably count to 5. You might make a mistake. Worse than that, I might go and change this and add an extra element in here, like that, and now this code will still work. Whereas if I typed 5 in there, it wouldn't work anymore. It wouldn't print out all the elements in the array, because this code here will figure out the length of the array, and it's done the right thing. All right, last of all, we can write the shorthand way of doing this, and that is we just say this. We just say for int v, or value, let's say value to spell it out, in A, oops, I'm trying to work out what to write here. Something like that. And then what it's going to do is it's going to go and get, oh, I've printed the wrong thing here. I meant to print the value. Okay? Like that. Oh, man. Okay. All right. So what that should do is take all of the elements of A and give them to me one at a time, which is nice because it gives us a really nice succinct loop construct. That's a lot more succinct than that, and it's a bit more clear as to what's going on. It's taking all the things out of A and giving them to me one at a time. Let's run it. What's the disadvantage of this? Can anyone see why this is a little bit more limited? Yep. Now, I couldn't hear you clearly, but I think you said you don't know what the index is. Is that what you said? Yep. That's right. So I don't know. I know if we look at this here, the value is 21, but I don't know where 21 came from. Okay, whereas in the other one it said, oh, the sixth element of A is 21. Here all I know is I got given 21. All right, and then with that we will take a very short break. If you're, oh, question online? Yep.
Online. So is a for loop just a syntactic sugar for a while loop?
Yeah, it is. It is. It's a cute way of writing a certain sort of while loop. Okay, it's. I wouldn't use exactly that phrase in English because it's not the same as, it's a syntactic sugar for a certain style of while loop, okay? So it's a certain form of while loop that you can do. You can't make all while loops out of for loops, but you can make all for loops out of while loops, okay? So while loops are more general, all right? Any other questions? If not, just take yourself a really quick break and we'll get on with methods in just a minute or two because we're a little bit behind, so I will keep going. I'm happy to answer questions, other questions while we wait. If you feel free to go stretch your legs for a minute. If you don't want to stretch your legs, feel free to ask me any random questions, admin, anything. Ask me anything if you'd like. Except how to fix your broken computer.
In check for the 65, the input, let's say if we go to here, the input of this one, right? This is the input that you require. It come out, if you see 3, this should be $sign. Yes. should be dollar sign, not the things.
Oh, the wrong sign?
Yeah, that's the wrong side. It should be the dollar sign.
Ask Leo. I'll need to, I don't have enough
That's
brain power to answer that right now, because I need to check, I need to read the details to be able to do that, of the question. I don't fully know the question, or at least not in my head right now.
Yeah, sure.
But I understand what you're saying. I'll need to check. I can go and check over here, but I can't, Leo may be able to answer it better. Hey Leo, can you just try forking the assignment wrapper? Just try and fork the assignment. Oh no, you can't, don't worry.
Why did it print do I equals 3 if you kept incrementing it? Shouldn't it not print anything at all?
Can you ask Leo?
Okay.
I just don't have it in my head. All right, folks, we fixed that technical problem with the assignment, so you can now see assignment 1, and you should be able to fork it. It should be all good. I'm going to blast ahead now with where we left off, which was, where are we? Great. Yep. We're now going to go to the next unit, which is J7. So we talked about control flow, right? Everyone's up with that. We talked about control flow, and we talked about sequence and selection, and we just did iteration, right? That was going in loops. Now we're going to talk about another kind of control flow where you can jump. Instead of just doing everything in sequence, you can go and jump and do something completely different. Now, why would you want to do that? Okay, you jump and do something completely different, and then when you're in that completely different place, you do 1, 2, 3, you just go in sequence again, follow the same rules. But we've now got a new way of doing it. We're going to jump somewhere else and do this thing. So what that's doing essentially is wrapping up a whole lot of things in sequence and giving it a name. We call that a method. Okay, so you've got a method, it has a name, and inside the method is a whole lot of other imperative programming. Now, you wonder, why would we do this? The answer is what we call abstraction. We're trying to separate concerns. Now, if I wanted you to make me a really nice chocolate cake, right? One way to do that would be to say, now walk to the oven, walk to the drawer below the oven, pull out the tin, put some stuff inside of it, cut this thing out like this, put that on beneath that. Now go to that other cupboard, pull out the box that's shaped like this, which has the word SUGAR on it. And I could tell you, I could spell it all out like that and say, then go to this other drawer, pull out the special measure and fill it to when it's halfway and so forth, and tell you step by step. Or I could assume that you're capable of cooking, just to say, hey, go cook the cake that's on page 47 of our favorite recipe book over here, right? And what's happened there? Instead of me standing there and telling you every single step of how to make a cake, which you might do with a toddler or with a small kid, I've abstracted it out and said, hey, can you please make the cake that's on page 67? And the instructions are all there. So all the instructions are now captured in what we call a recipe. That's what recipes are all about, okay? In real life, we don't tell everyone, whenever we ask someone to do something, we don't ask them in minute detail to do each step. We wrap it all up in an idea, in a name, and in the example of cooking, we often actually literally write down those steps in what we call a recipe. And instead of always going back and telling the person to do this one thing, we just say, please go to that recipe and make the thing that's already described there. Okay? A method's like that. It's capturing a whole lot of steps, giving it a name, and then putting it aside. Okay? And it's hiding the details. If I'm, I may not want to know the details of how to cook this cake, right? I don't want to sit around and watch the whole process. I want to be able to put that detail aside and let the other person deal with that. Or conversely, you may be asking me to do it, right? And the same concept applies to so many things we do. Like I said before, when I showed you the jet engine back in week 1, we don't want, if we're the pilot of the plane, we don't want to have to be responsible for knowing how the jet engine works. We just like to know that when we move the throttle, there's more energy produced by the engines and we'll get lift on the plane. We want those concepts to be clear, but the mechanics of exactly how that really, really complicated jet engine works, we don't want to know about it, right? We just want to know the things that matter to us, which is how the throttle works and how it impacts the kinetic energy of the airplane and how that affects lift, okay? We want to work at that level of abstraction, not at the level of bits of kerosene flying around pipes and ignition and all the rest of it, okay? That's abstraction, and methods are about abstraction. Okay, it's about grouping together a bunch of ideas and giving it a name. So let's go through here. A method is a subroutine. It's reusable, okay? So now, instead of sitting there and trying to remember how to make this cake, I just say, go to page 67, and you can make the same cake every week, right? Or the brownies, or whatever it is you're making, you can make the same thing because it's all written down. It's reusable now, okay? We don't just dream it up each time. We reuse the same thing. It's reusable. They can take arguments. I can say to you, oh, that cake parameter, I want you to actually make 2 of them, or I want you to make one that's half size. In a bunch of my, I like cooking by the way, in a bunch of my cookbooks I've actually gone and worked out, okay, if you do it in that size pan, then you want to cook it for this amount longer or whatever it is, right? You've got all those stuff written down. So I say, oh, make me a 1.5x recipe, or make me a 2x recipe, or make me a 1x recipe, or whatever it is, right? That's a parameter, okay? So I'm saying, make me the cake, and then I'm telling you one other extra bit of information, please do this. Or it might be a smoothie. So you know how to make a smoothie, I'll give you instructions on how to do it, but I could parameterize the fruit. So make it with berries, make it with strawberries, make it with banana, whatever, right? That's a parameter, okay, to the recipe. And it may return a value. Your cake's going to return a value, the cake, right? The smoothie's going to return a value, the smoothie, right? We can return something, or it could just return nothing, okay? Sometimes they return nothing. They just do something, and then they don't actually deliver something at the end. That's also okay. In Java, when it's nothing, we call that void. Okay, that's just the technical word, void. And if you know science, you'll know the word void actually, or English, void means literally nothing. Okay, method declaration. When we write one of these recipes, which we call a method, you have to say it in a very particular way. You've got to, first of all, put modifiers on there. And the first modifier you do declares how visible it is. Okay, you can make it public or you can make it private. Now, we always prefer to make things private if we can. Why is that? Is it because I'm shy and introverted and like everything to be private? Or is there some other reason? Yep. Sorry, you can't hear each other, but sorry, go ahead.
Oh, I said in private you want to have variables that don't clash with other bits of code.
Yeah. Yeah, you want to contain your mess, as it were, right? And you don't want to have to know. It's like the jet engine thing again. It's like we don't want to know about what's going on there. Just keep it to yourself. Just make sure you get the job done, right? We don't want to know all the electronics inside the mic that's delivering this audio, right? We just don't want to know about it. This is a little black box that sits there and we just have an on switch. We don't want to know how to build an op amp for an amplifier that sits on your hip, right? That's just beyond what we need in order to deliver a lecture right now, okay? So we're containing the mess and we're keeping it private, okay? That's containment. It's a very important principle in computer science, containment, okay? So it's the opposite of when your housemate has all their laundry spread out all over the floor or whatever. You contain your mess, keep it contained, okay? We declare a return type. The return type could be an int, it could be a string, it could be any valid Java type, or it could be a void. We have a method name, so we have a name for a method. We often like to use verbs to describe the action that's happening, because methods are so it might be make a cake, right? Or whatever, okay? So it's an action, okay? A method is a sequence of steps, so we often name them according to what the action is, okay? Or it might be a question, like the thing might be evaluating a question, so then you name the method to give the human who's reading the code a sense of what the purpose of the method is. Yep. Are there naming conventions? There are naming conventions which I went through last week about the actual case of the letters and so forth, and you use a lowercase letter in Java, and you use camel case if you've got multiple words in the one name. You can't have spaces in it, so you use uppercase for the next start of the word. Beyond that, the naming convention is try and make your intentions clear. Okay, and that's obviously the computer's not going to check that. That's something for the human reader to check. Yep.
A question for Ethan. How do Java's methods compare to functions in C?
How do Java methods compare to functions in C? Very, very similar. Okay, very similar. Java methods are very similar to functions in C. There's one very distinct difference which we're going to come to soon, and that is that you can have a method that operates with respect to a class. Remember before the example of the bike, right? The bike, we have classes and we have objects. And we're going to emphasize this in the remaining part of the lecture, which reminds me I need to hurry up. But we've got instance methods and static methods. And we don't have such a concept in C. But the idea of a function in C is very similar to the idea of a method in Java. All right, and then finally we've got the body method, okay? And we've got exceptions. We're going to describe exceptions in detail later in the semester. So don't panic at this point when you see the word exception. That's just about whether this thing could be badly behaved, which sometimes is intentional and well designed, and so we can actually declare that it's going to behave in a certain way. But we'll come to that in much more detail later. And finally, you've got the body of the code of the method, what it's actually going to do. So the last person's question is preempted by preempts this slide up in front of us. Instance methods and class methods. We can have a method for a class, so that's like the method for that type of bicycle. So the method might be, tell me the 1-800 number for the warranty inquiries. So that might be a method that you offer for that type of bicycle. So for any bicycle of that type, you always get the same 1-800 number. But the method for the instance might be go go faster or go slower or turn left or turn right. That's about the actual concrete bicycle. The method for the bicycle type is something that's relevant to all bicycles of that type. So tell me the warranty details or something like that. All right. Parameters, these are the parameters I told you the example of the smoothie. Make me a banana smoothie, make me a strawberry smoothie. That's an argument, if you like, a parameter to the recipe for making smoothies. And, or the size of the cake might be a parameter. And they're a mechanism for passing information to the method or a constructor. So you pass them by value. So if I give you an int, the method that receives that int gets its own copy of that int. So if I give it the 5, it has as its argument its own value of 5. Likewise for a reference, but if I pass you a reference, it gets its own reference, but the reference is going to refer to the same thing. So this will become clearer when we see a Waterloo example, okay? So don't panic if you don't understand this. But we use references to refer to objects. If I give you a reference to a dog object or a reference to a cat object, and I pass that reference to you, then you'll get your own reference to that same cat or dog. Okay, so I'm not passing you the cat or the dog. It's not like you get your own cat or your own dog. You're going to have a reference to the exact same cat or dog, but you will have your own reference. Okay, so it means you get your own reference, but it's a reference to the exact same cat or dog as the one I started with. All right, you can have what in Java we call varargs. Other languages have this, which means that we could have an unspecified number of arguments. Okay, so you have more than one argument. You can have it not actually declared how many arguments there are. That's called varargs. But we won't go into that in any detail in this course. Returning a value from a method, when we write the return statement, we can return a value. So I can return your smoothie, return your chocolate cake. And we can do that by putting the value after the return statement. You'll see as we work through examples what that means concretely. So methods return to the caller when you get to the end. You've seen that every time I've run the main method, you've seen that happen. When we get to the end, it just returns. We're done. Okay, when it gets to the end. Okay, or if it's supposed to return a particular type, I've got to write the word return and then the thing we're going to hand back, the number 0, the number 5, or whatever it might be, depending on what type it's expecting to return. If the method throws an exception, it needs to do that. It will go back to the thing that called it. Exceptions, again, we're going to cover them in detail quite a bit later in the course, so don't panic. We're going to go into that a lot more detail later. Methods that are declared void do not return a value. I've said that to you a few times already. And what's a void method that you already know? Anyone? The main method, right? The main method doesn't return a value. You see public static void main. It means it doesn't return a value, okay? Okay, mini quiz time. Okay. And by the way, folks in the lecture, some people came and asked me questions during the break. One of the things I struggle to do while I'm trying to fix your assignment up and also deliver the lecture is I often don't have enough context in my head to be able to answer your question quickly. But you can feel free to post them to the same Teams chat, and it may be that Leo can give you a quick answer, or Leo can rephrase your question in a way that I can quickly answer it. So don't be afraid if you're in the physical room to use the same chat as those who are remote. Okay, next, here's a method. Okay, we're going to do this nice and quick now because I am running late.
Steve, I think you need to switch to another scene.
Oh, yeah? There we go. I haven't done anything interesting yet, folks, so don't worry. Okay, now we're going to write ourselves a main method. But before we do that, we're going to write ourselves a method up here. And the first one we're going to do is a void method, which will do nothing. At the moment, we're just doing static methods. In a few minutes, we're going to move to objects, in which case we'll go beyond just main methods. So I'll do the following: private static void. I'll have a very exciting method here. It's going to print out boo. Okay. That's it. That's our method. And then what we're going to do is we're going to say we're going to call the method, right? Now this method doesn't have any arguments, so I can just go like this. Now what's going to happen is when we run the program, it will go to the main method, and then it will go and execute the boo method, right? And let's see what happens when we run this. Run. Okay, and there you go. And if we print something out beforehand, like this, in main method, you'll see that getting printed out first. Okay? In main method, then boo. Now, let's do something slightly more interesting, and we'll have a new method called add, which is also pretty silly because we can just use addition. But anyway, let's just imagine we wanted to do this, static. And if I'm going to add two numbers together, what return type should it have if they're going to add two ints? It's going to return an int, and what parameters should it have? What parameters might I have? Yep. Yeah, it's going to have two parameters, and that could be something like this: int A, int B. And I'm going to add together A and B. All right? And then I'm going to say something like this. I can say return A plus B. And then I can also print out what things are. I can say S out, A is, and then print out the value of A. And then I can say B, comma, B is, and then the value of B. B. And then down here, we can call it, we can say int C equals add 5, comma 6. And then we can say, here we can say S out, the answer is, and then print out whatever C was, like that. And run this thing. And what should happen is we give 5 and 6 to the method add. It takes 5 and 6, prints them out, and then it adds them together, and the answer is 11. We can do something else slightly more interesting by like this. We can say int x equals 5 or 6 or whatever. It doesn't really matter. Say 12. And then we can put in here x, okay? Now what should happen is it should print out basically the same stuff, but this time it'll print out 12 and 6, which is 18. Okay, let's have a look here. Yeah, so A is 12, B is 6, the answer is 18. Notice that I call this variable here x, and up here it gets passed in. In here it's treated as the variable name A, the parameter A. Okay, I could have called this A just to be even more confusing. I could have done this. And then we have two A's, the little A here and the A up there. Okay? Can do this, but let's just put it back to being x. And something else curious, what we can also do in here if we want, we can do the following. We can say int x equals 42. So now it's got its own x, which is a value 42. Okay? And we can run this, and that x of value 42 has no consequence at all for what we're trying to do, because this sum is between A and B, which are 12 and 6. And so we get the same answer back. We can quickly look at that in the Waterloo visualizer. I think I did something like this in the Waterloo visualizer, which I would like to show you. And then I need to move on to Waterloo visualizer. Then I need to move on to this. Have I done something like that here? I have. Okay, so let's quickly visualize this example here. So we go step here. And first of all, we've got a main method. We've got x whose value is 10. Okay, we're printing that out. X is 10. Then what we're doing is now we're calling the method boo. Watch what happens to the stack when I do this. Well, look, the main method is no longer blue, it's white, and we've pushed what we call a new frame, which is for the method boo. Notice that boo here, hang on, I'll just keep going. It's at line 3. Now we're at line 4 of boo, and it's got its own x, which is 12. We've got an x here, which is 10, and an x here, which is 12 in this example. We move to the next line, it prints out boo. Okay, and it's got a return value of void. It has no return value. Okay, we step forward and we're back into here again. Okay, so we're finished with boo. Now what we're going to do is print out the value of x, and x is still 10 because this is the x of the main method, which is 10. Okay, now we're going to call add with 5 and 10 as their arguments, and in this case I call them x and y. You could have called them a and b. It doesn't make any difference. Okay, so now I'm going to call the main method, that add method. Now I've got a new frame for add. We're at line 8. We've got x whose value is 5, y whose value is 10. Step over that, and we've got a z there whose value is 15 because it's added together as 5 and 10. And now it's printed them out, and we've now changed the value of x to 100. Notice when I did that, it does not change the value of the x here. They're unrelated because this is only changing the value of x in the context of add, not x in the context of the main method. Okay, and then it returns its value, which is a void value here, which is a bit strange. In my example, I had an int return value, but here we've got a void return value. Okay, and we're back where we started, and we're done. And we step one more, and it returns void. The main method returns void, and we're done. Okay, and with that, we're ready to move on to the next one, which I really wanted to get into because this is a really important part of the course. And you're going to see this in the assignment, objects and classes. So let's take a look here at objects and classes. I've told you about objects before. Now, folks, if I go a little bit over time, if you could just quietly leave if you've got something to go to, that I totally understand that. I would like to try and finish this off, okay? So I may go slightly over time. I apologize for that. If you do need to leave, just leave quietly, all good, okay? But I will just forge ahead. All right, so objects combine two things. Can anyone remember what I said? I said it last week sometime. Anyone? Yep. Objects come from a class. I feel like a class is the blueprint. Two ideas. I was going to say objects combine two ideas. The two ideas are state, which is like data, and behavior, which is like code. Okay? State and behavior. That's what objects bring together. Object-oriented languages are defined in terms of combining state and behavior. All right. So when we do this in Java, we create classes and objects. So we're talking about the mechanics here, the mechanics of how we actually do it in writing Java code, which is not very interesting, but you need to know it because you can't do it unless you know these mechanics. It's like the really exciting part about cooking is not learning how to turn the oven on. But if you don't know how to do that, you're not going to make much of a start on cooking the cake. But you still need to know how to do those details, right? So we're going to go through some of these mechanics. And like I said so many times in the first week or so of this class, some of this won't make sense until you've seen it lots of times. And we're going to go through it again and again with lots of examples like I've already been doing, okay? I'll do more and more examples. This will become more and more familiar to you, and these ideas will make more sense, okay? So you've got a declaration, same sort of tedious thing we saw with the methods. You got a declaration. First of all, you have these modifiers again, which describe the visibility level. And again, we prefer to be private, okay? And then you've got a keyword. You've got a special keyword, which says class, which is how you declare the class. What's the class? The class is like the example of the bicycle class, okay? The bicycle class. And we know that we've got a class because we use the keyword class at the top. And if you go back and look at all the code I've written, you would have seen this happen every single time. Okay, IntelliJ does it for you. I haven't been typing in CLASS each time. It's done automatically for you. All right, then you've got the name of the class, and by convention, we always use a capital letter, the first letter of a class. That's a convention in Java. And then you've got optional superclasses names, which is when you have inheritance. I discussed very briefly the idea of inheritance before. We talked about an apple being a kind of fruit, which is a kind of thing. And in Java, we call a thing Java-lang object. We talked about a bicycle being a kind of vehicle, maybe, and so forth. And these are inheritance hierarchies. It's very, very obvious to those of you who've done any biology. You understand the hierarchy of animals, okay? Same concept. Then we use the word extends. So if we have apple is a type of fruit, we'd say apple extends fruit. That's the language we use. That's the way we write it in Java. Okay? And then we can say it's got an interface. And remember, I talked about interfaces before. I said an elephant, a donkey, a car, and a fighter plane could all be vehicles. They can all be vehicles. They're totally different kinds of things, but they all have the property of being vehicles. In that case, we could say they implement the vehicle interface, which has a stop, start, left, right type interface maybe, okay? And we use the word implements to do that. That's a contract that says this elephant can stop and start and turn left and right. This fighter plane can stop and start and turn left and right. It's a contract that says that if you say turn left, turn right, this class will respect that, okay? So it's a contract. That's how that works. And then finally, you've got the actual content of the class, which is in braces. Member variable declaration. There are three kinds, classes and instance variables, which we call fields. Okay, you've seen that already. Okay, classes, instance variables, and class variables. And I went through high-level examples before with the bicycle. Okay, a field of the bicycle class, okay, a class variable of a bicycle could be something like how many gears does this kind of bicycle have? This bike's got 18 gears, or it's got 1 gear, or whatever, it's fixed. Okay, that's a property of all bikes of that type. Okay, so that field, how many gears, would be in the class. Okay, then you've got something for the instance, which might be the current speed of this very bike right here. Okay, and that might be velocity. Okay, and every bicycle of this type might have a different speed at any given moment in time. Okay, so that's an instance variable. Okay, so the how many gears thing is a class variable. The current speed of the bike is an instance variable because it describes something about this exact object, not the class of objects. Variables within a method, which are called local variables. You saw that before. We used x and a and b we used x as an instant variable, and we used I a lot in the examples I've given you. And then you've got a method arguments. We used that in the last example where we had a and b being arguments. Remember that? So they're arguments. So there are three kinds of member variable. And you also can declare them as public and private. All right, constructors. A constructor is like a special method. It's not literally a method, but it's very much like a method. It doesn't have a return type. This is how you create a new object, and you can set the object up to have certain attributes. This is a really important thing, and you're going to see it as the very first task in assignment 1. So if you go and look at assignment 1, you're going to have to mess around inside of a constructor. Thankfully, your task is pretty simple in task 1. But you will have to have some idea about what is a constructor anyway. Well, you actually don't. You can actually do it without even understanding that, but it's probably better if you do have some understanding of that. So we'll step through an example very, very soon, okay? And you're also going to do the same sort of examples in your labs this week, okay? So if you're still feeling at C, we're going to step through it in the lab, all right? So then constructors are like normal methods. They do not have a return type. They don't even return void. They have no return type, okay? That's what a constructor looks like. And they have the same name as the class. That's the other special thing about a constructor. So if I've got a bike class and I've got a constructor which makes new bikes, the name of that method is bike, exactly spelt the same as the class. Okay, that's a convention. And it doesn't return anything. It doesn't return void, doesn't return int, nothing. It's just bike, okay? And if no constructor is provided, there's a default one. And what do you think the fields will become if you don't have a constructor? The constructor is used to set up the new object, okay? So you can set up to be however you want, but if you don't do anything, can anyone guess what happens? They get default values. So if I have a Boolean, it'll default to false. If I have an int, it'll default to 0 and so forth. There are default values for everything. So if I give you a new bike object, it'll have a default velocity of 0. It'll have a default name of empty string and so forth, or null, sorry. It'll have default values for everything unless in the constructor you specifically construct them. Okay, we're going to work through a concrete example in just a moment. To create an object, first of all, you declare the reference to the object, and then you instantiate it with the special new keyword. Okay, that means create me one of these bikes, create me one of these fruits, one of these apples. Okay, and then the initialization will happen in the constructor. We're going to work through a concrete example in just a moment. Using objects, when you want to use an object, to access fields in the object or methods in the object, we use the dot operator. So we can say, say you've got a bike called B for bike, right? Lowercase b. And if I want to say, give me the velocity, it might be b dot velocity. The dot operator says, give me the velocity of B, the bike B, okay? And if I want to access the class's number of gears, I'd say capital B-I-K-E dot number of gears. That's the variable that is the number of gears. The dot is the way you access it, okay? But when you're inside of the class, you don't need to do the dot operator. There's a shortcut that gets rid of all that stuff, okay? It's, as someone said earlier, syntactic sugar. So to call an object method, same thing. If I want to do the go faster, turn left, turn right, if I say b dot turn left, b dot turn right. If my method is actually, if my code is actually inside of B, then I don't need to say B dot, okay? I can just say this dot or just not say anything. I just say turn left, turn right, okay? But if I'm referring to it from outside, I say B dot, turn left, turn right. Again, this is going to make a lot more sense once we work through an example. Time for the mini quiz. And then we're going to work through this example, and we're just about done. Now what I'm going to do is I'm going to create an example of a person, very simple person. 001 is the unit, not 002, and it's going to be called, what is it going to be called? Person. Okay, what's an attribute or a field that describes an individual person? What's like the most basic thing we might use to describe a person? A quality. Yeah, perfect. That's exactly what I was fishing for. Okay, so let's do that. So we're going to declare their name. We'll say private. What type would the name be? Can anyone guess from your vast knowledge of Java what type might you use for a name? Yep. Perfect. String. Okay. String name. There you go. We now have a person, and each person will have a name. Okay. So we've declared a class person, and we've said that everything of type person will have a name, which is a string. What other thing might we want? We can put whatever we want here, but let's just make something else up. What other thing might we use to describe a person? Let's just say their age, okay? So we say int age, okay? We can also make that private if we want. We don't have to say private here. We're just doing that because we're private people. We don't want others to see this stuff. All right, so then what we're going to do is we're going to write ourselves a constructor for making one of these people, okay? So we'll say person, and then there are two fields that we probably want to initialize when we construct. If we don't do this, actually, I'm going to go off script here because this may help you. Right, let's first of all create a main method. Oh, actually, there's one more thing that we can do for every type is a toString method. ToString method is a really useful thing that you're going to get used to writing all the time in Java. ToString turns an object, like that person or that person, into a string, which is useful because often you want to print out the object. If you just print it out, it looks pretty ugly. If you have a toString method, you can print out something useful. Okay, so let's just write ourselves a toString method. What's interesting is we're going to introduce to this idea of override. Right. No, that's not what I wanted. Okay, IntelliJ is not smart enough for this. Okay, so public string toString, and we're just going to return a string here, and the string's going to say the name, and then we're going to concatenate that with a comma and the word aged, and then we'll print out the age, right? Does that make sense? So whenever we print someone out, we'll say, you know, Fred, age 21, or whatever it might be, right? So age. Notice that it's colored in age and name in that sort of mauve color. That's telling us we're accessing fields of our object. We're accessing the name field and the age field of our object. That's what it's telling us there. Okay, so we've got an age and a name, and what that means is now we can print out one of these people. So now let's create ourselves a main method, which we can do in a separate class if we want, or we can do it in this class. Let's do it in this class just for speed, PSVM like that. And now we're going to create ourselves a main method, and what we can do is make a person. Fantastic. So we say person, declare it. Fred equals new person. That's it. We just created a person. And now we can print something out. We say sout Fred, what we made, and then do this. Now, what is going to get printed out? Can anyone guess what's going to get printed out? Oh, that's not what I wanted. Fred. Can anyone guess what's going to get printed out when I run this program? Yep, in the blue. You. Yep, blue jacket. Yep. Fred then 0? Yeah, great. What? Hang on. Okay, Fred then 0. Does anyone have any other guesses? Yeah, at the back, nice and loud. Just a comma, then the word age. Comma 0. Fred 0. Fred 0, comma 0. Any other guesses? This can be like an auction here, folks. Do I hear another? All right, I've got two pretty good suggestions. So I'm going to run with those two suggestions. They're both good ones. So hands up for Fred, comma 0. I think there's going to be a lot of people not putting their hands up here. That's my guess. Okay, hands up for comma 0. Hands up for this is tricky. Yeah, it's all right. Okay, let's run it. Of course, that's the way we can find out. So let's just run this thing and see what it says. Run. And neither of those were exactly right, okay? But the person there who said nothing was pretty close, just a comma and then 0. What's going on here? What's happening is we did not initialize the name or the age. What's the default value for the age? I said that a moment ago. It's 0 because it's an int. Ints get initialized to 0. String is an object. If you don't initialize a string, then it will be null. Not empty string, but null, okay? So we've created ourselves a person with no name and no age. So when we went to print it printed out something not very pleasant up there on the screen, okay? So that's interesting. We want to avoid that, right? And the way we avoid that is by having a meaningful constructor. And so what we're going to do now is write ourselves a constructor. We're nearly finished this part of the lecture, folks. We're very nearly finished the whole lecture. So what we're going to do now is we're going to write ourselves a constructor. And now what we're going to do is pass as arguments the age and the name. String name, like that. And then we'll say this to differentiate the argument age from the instance field age, we're going to say this dot age equals age. And then we'll say this dot name. Actually, let's switch these around because that's actually, it'd be more helpful for what I want to do next to do it this way. Let's do it like that. It doesn't really matter, folks, but it's just slightly more convenient for the way I want to tell the story. Like that, do that. This dot name equals name. Then what I can do is I can create another person. Now it wants us to use that constructor because there is a constructor there. So now what we can do is we can say person, and then we can say Fred, and then get, or Fried, whatever, Fred, and give them an age of 20, like that. We run this, and now what should happen is Fred gets constructed. They have a name, which is Fred. They have an age, which is 20. And then when we print it out, it should print out something sensible. Okay, like this. When you do your lab, you're going to work through an example just like this. Okay? And we made Fred age 20. So it's printed out just what we wanted this time. Okay? Because the string is no longer null, the age is no longer 0. Now what we can do is do one more thing. And just to emphasize, we can have multiple constructors. So imagine we get the person, but we don't yet quite know what their age is. So we can create the person and then later set the name. Then we can say this dot name. Name equals name. And then we can say same sort of thing here, but we create another person. Say Mary. And we'll delete this. I'm trying to be as fast as I can here. Now, Mary won't have an age, so the age should be 0. Okay, so let's just do that. And the last thing we're going to do is we're going to write ourselves a special method that allows us to set Mary's age. And that's called a setter method. We'll do that. And then we've made Mary age 0. And now we can say, write one more method here, which will be public set age. And IntelliJ figured out exactly what I wanted and filled all that stuff out for me. I didn't just type that really fast. And then we can say here, we'll just repeat this after having set the age. And how do we set the age? We call the method on Mary. So Mary.setAge, set age, and give her an age like that. And now Mary should have an age, so it should print out twice. The first time with an age of 0, second time with age 21. Question?
So where you can define the age without defining the name first?
I beg your pardon?
Where you can define the age first and then that way.
Is there a reason why I did it that way? No.
Okay, is there a way that you can define age?
Can I define? Yeah, sure. I can make another constructor which doesn't take name and just takes age.
Like
Pardon?
By typing in like typing in new person, do you do comma age, or do you have to?
No, I've got to set it. I've got to create. If I want to only give the age, I'd have to make a new constructor which just took age as an argument. Okay. So anyway, you can see here that worked. Now we've finished with that. I want to finish with the bio, which is very fast and very important. So please just bear with me for a second. Who's heard of Konrad Zuse? Okay, I want everyone in the room's hands up. No. This is really sad. Do you know why you haven't heard of Konrad Zuse? He was one of the greatest computer scientists of all time, and most people haven't heard of him. Why? Because the poor guy was on the wrong side of the war, and history forgot him. He was one of the first people to develop a fully programmable computer. He was one of the first people to develop a high-level language, and the first person to make one of these things actually work in practice. Okay? But the history books basically wrote him out because he was in Germany at the time of World War II, or just before World War II. Most people have never heard of this guy, but he's one of the most remarkable computer scientists around. And I want everyone to remember that because I think it's very important that we don't brush over bits of history, particularly ones that are as important as this, where the person invents the first computer. And of course, our American friends would love us to think that it was all invented in America and the ENIAC was the first computer, but that's not quite entirely true. All right, with that, we're going to finish off. Have a great week. Don't forget to go to your labs. Your tutor assignments will happen tonight. Make sure you go to your labs on time, and I'll catch you on Friday.